Hi, good day everyone. Grade 7. Our topic for today is all about scientific notation. The learning target is I can write numbers in scientific notation and vice versa. Watch and learn. So in this lesson, we will answer these following questions. What is scientific notation? Why are numbers written in scientific notation? What are the advantages of using scientific notation in measurements? And how do we write numbers in scientific notation and vice versa? For the video, just follow this YouTube link. What is scientific notation and why do we use it? Working with a very large or small quantities usually ends up being quite complicated. Scientific notation is a way to write numbers in an abbreviated way, making it easier to work with this number. Did you know? What is the Earth's age? The age of the Earth is approximately 4,600,000,000 years old. That is quite old. And to read these numbers short, or to convert this number or to write this number in much easier way, we can write it in scientific notation. So that will be 4.6 times 10 to the power of 9 years old. Then what is a scientific notation? Scientific notation is a method of writing very small or very large numbers into manageable lengths. Note that the scientific notation is based on the powers of 10. So here for the example, we have the 8,000,000, 8 with the 6 zeros. To make this number short, we can just simply write 8 times 10 to the power of 6. What is coefficient? In scientific notation, it is the number multiplied to the power of 10. Its absolute value should be greater than or equal to 1 but less than 10. Note that the units digit of the coefficient is first non-zero digit from the left of the given number. So in this case, we have 8 times 10 to the power of 6. The coefficient is 10 because, the coefficient is 8 because it is the number or the digit multiplied by or multiplied to the power of 10. Next, what is a base? The fixed value 10 in a scientific notation. So in this example, we have 2 times 10 to the power of 9. And the base here is 10 because 10 is raised to the 9th power. Okay, so here in this example, 10 is our base. What is exponent? In scientific notation, it is the exponent of the base which should be an integer. So remember, when we are talking about exponent, this should be in integer. So here is for the example, 4 times 10 to the negative 6. Okay, the exponent would be a negative 6. And as we can see here, negative 6 is an integer. Okay, see for this example. We have the given 125 million. Okay, to make this number short or to easier write this number in a shorter form, okay, we can just write 1.25 times 10 to the power of 8. Why is that? Okay, so we have here the imaginary decimal point. So there is always a decimal point in the right side of one's place. So we have here, okay, we can just move from the right to the left, going to the left. So this would be 1, okay, 1, 2, 3, 4, 5, 6, 7, 8. So we move the decimal point up to this point. That's why it becomes 1.25 times 10 to the power of 8. Okay, why did we put decimal point in between 1 to 5? Okay, there should only be one digit to the left of the decimal point to get out all the factors of 10. That's why we should have only one digit left in our scientific notation. Here is the next example. We have the given value 937,000. Now, how will you write it in a scientific notation? So, as I have said earlier, there is always be a decimal point at the right side of one space. So, where is the one space? This one. Okay? And we shall move it to the left. 1, 2, 3, 4, and 5. That's why we put or insert 0 here in between 9 and 3. And again, there should always be one digit to the left of the decimal point to get out all the factors of 10. Okay, and the answer would be 9.37 times 10 to the 5th power. Okay, again, the power is the expression, this one. 5th power, or the power, is the expression that represents repeated multiplication of the same factor. So in this case, we have here the base, the power, in the coefficient. Okay, and for the exponent, it corresponds to the number of times the base is used as a factor. Okay, so next would be 4,500,000,000. So how will you write it in a scientific notation? So again, move the decimal point from the right to the left. That's why 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we shall move the decimal point here in between 4 and 5. Okay, that's why the scientific notation of this value would be 4.5 times 10 to the power of 9 to reduce all the zeros in this given value. So next example, how about if the given value is small or less than 1? So we have a decimal point here. Okay, so in opposite direction from the left to the right. So again, just leave one number or one digit to the left of the decimal point. So we start from here, going to the right. So 1, 2, 3, 4, and 5. So this is where we can put our decimal point. Okay, that's why our scientific notation for this value would be 5.03 times 10 to a negative 5. Okay, and this one it expresses that the value is smaller. So because it indicates here in the integer or to the power of a negative 5. So it means that the number is smaller, okay, or less than 1. Okay, so next example, how will you write this in a scientific notation? So for this one, same procedure, we just need to move it to the right. So 1, 2, 3, 4, 5, 6, and 7. Okay, we shall put here the decimal point. That's why our scientific notation would be 6.8 times 10 to the power of negative 7. So that will be our scientific notation. Okay, so it is smaller number, it is a negative, and less than 1. Okay, so next. Okay, this will be our problem involving scientific notation. So we have the distance between Earth and Mars in approximately 225 million kilometers. So I would like you to write this in distance in scientific notation. So next, the light travels at speed of approximately 3 times 10 to the 8th power. Write the speed of light in a standard form. So how will you do that? For this one, the distance, we have the given 225 million kilometer. So again, write 225 million in standard form, which is this one. Okay, this example. And we shall move from the left to the right, move the decimal places, and that gives us 2.25 times 10 to the 8th power. So that will be our scientific notation of the given value. Okay, so next problem. Light travels at a speed of approximately 3 times 10 to the 8th power. Write the speed of light in a standard form. So again, we have the given 3 times 10 to the 8th power. Okay, so you just need to move the decimal point 8 to the right. Okay, and that's why we have here the value of 300 million meter per second. So that will be our answer. Okay, so thank you. That's all for today. I hope you learned. Thank you. Bye bye.